Welcome to Study Session with Schmidt. This is your test makeup video. Here we're going to incorporate Edpuzzle. So let's go ahead and get started. All right, so when we are making a measurement, we have to always report what we can see on our instrument, and then we have to give one estimate. So if you're looking at ruler A, right here is ruler A, we see that we can only be certain of 0 and 10, and let's say this is in the units of centimeters. We didn't write it on there, but it's in centimeters. So we only know at 0 and 10 centimeters. So everything else we're kind of guessing. And so we only get one estimation here, all right, because we can only guess between 0 and 8. So it's one guess or one estimation. If we look at choice A, we see that that says 0.8. Well, 0.8 is going to be something really close to 0. This is really way over here closer to 10. So we can see that that is definitely not going to be the correct answer, even though that would be one estimation. It's really way over here, and the line is way over here. So that is not going to be the choice that we want. If we look at choice B, we see that we have one estimation. One estimation, we see 0. Where is this measurement between 0 and 10? We're going to guess at 8 centimeters. And so you're at one estimation. So this is the correct answer. Now, if you look at choice C, you want to know, well, what is wrong with choice C? It looks like it's good. It's not much different from choice B. Well, the real difference is that you have two estimations, all right? Because here you have an estimation. That's estimation 1, because it's a guess. You don't know. You can't see 8 on your instrument, so 8 is clearly is a guess. All right, we don't know. Some people might have said it's 7. All right, but so that was an estimation of 8. And then this is a second estimation. My pen is not working with me very well, but this is your first estimation. This is your second estimation. And you can only have one estimation, all right, or guess. If you look here, here is the first estimation, second estimation, and third estimation. So there's 1, 2, 3 estimations. You only get one. Let me make sure that's very clear. You only get one estimation. You can only have one estimation. All right. Only have one estimation. Let's put this, make it, you only have one estimation. That's all you get. You do not get more than that. And so choice B gives you just one estimation, and that's what makes that correct. All right, if we go to ruler B, here we have, it's a little bit different than ruler A, you may notice, in that it has more tick marks, all right? You can see the dimensions at 1 centimeter, 2 centimeter, 3 centimeter, and 4 centimeter. In ruler A, you could only see it 0 and 10. So here, you are not making an estimation when you simply say 2, because you know it is somewhere between 2 and 3 centimeters. So if you look at choice A, this 2 now, even though it's one digit, just like it was in choice B over here, it's one digit. Now it's not an estimation because you know it's at 2. So the problem here is it did not give an estimation. And because it did not give an estimation, that is not correct. All right. And let's make sure you know those two aren't correct. All right. Now, if you look at choice B has 2.4. It's guessing where it is between 2 and 3, and you're saying 2 I know of, 0.4 is my estimation. So that is one estimation, and you got it. You only have one estimation. So this gives one estimation, and it's a good measurement. If you look at choice C gives the digit you're certain of. I'm going to use a green here. This is a digit you're certain of. This is your, let's use blue. This is your estimation, and this is your second estimation. But you can only have, that's right, one estimation. So because this uses two estimations, this is incorrect. How many estimations do you see in choice D? 1, 2, 3 estimations. And because it uses 3 estimations, it's incorrect because you only get how many? That's right, 1. So there you are with choice B. So on your test, you're just going to make sure you're looking for what you can see on your instrument and then simply one estimation, nothing more. All right. And let's look at choice C. We're going to follow the same rule. Now this got a little more complicated, maybe not complicated, but it's got a little more dimensions on there. Here we see 1 and 2, and we see lines in between. All right, so now we can read this a little better. We can see that it's somewhere between 1 and 2. This is not an estimated number. We know it's between 1 and 2, but it is not making an estimation. So that is not correct. That's incorrect. We can see that it is at 1, 0.1, 0.2, 0.3, 0.4, and then there's 0.5. So it's somewhere between 1.4 and 1.5. This is what you can see. You can see 1.4, but this measurement does not give an estimation. And because it does not give an estimation, it is incorrect. If you look at choice C, you can definitely see the 1.4. We are certain of these, but then it gives this estimation, and that is just one estimation. And because we can have one estimation, or we're required to have one estimation, this is the correct answer. Okay, and then if we look at choice D, we see once again we have our givens. We can see for certain on our instrument 1.4, but then they do something a little bit incorrect. They guess and then they guess again. And you cannot make that second estimation or guess. You can only have one. So that makes this one incorrect. And so just watch for on your instruments when you're reading for your test that you're looking at what you can see on your instrument and then just only one estimation or guess afterwards. All right, and so now I'm going to put this up here. I'm going to leave this so you can view that for a second. And what I'm going to do is ask you a question in the video in Edpuzzle. So take a look at this for one moment. All right, and your question should come up in just a little bit. Okay, I hope you did very well on that part of your video here. We want you to get all those questions correctly, answer those correctly so that you can reassess and hopefully make that A that you're wanting. Okay, so on this one, we're looking at accuracy and precision. And accuracy is a measure of how close a measurement comes to the actual or true value of what is measured. Precision is is a measure of how close a series or multiple measurements are to one another. So let's say I have 3 trials. I'm going to use don't want to use red ink there. 1, 2, 3. And let's say I'm measuring the density of aluminum. Now, I went from the Handbook of Chemistry and got the actual value. All right, this is from a reliable source. This is the actual value of the density of aluminum. But let's say in my experiment, and you know this is experiment because I put it in a data table, right? So, and there's 3 trials. So anytime you see any data from the data table, it's probably going to be from an experiment, and it's going to be your experimental data. So just know that. So this is your experimental values. All right. So if you have density, let's say in trial in this first scenario, that we have, let's say 4.0 grams per milliliter, 2.0 grams per milliliter, and 1.0 grams per milliliter. And I were to ask you to describe the results here. Are they accurate or are they precise? All right, do they show precision? And so if we look and we want to look for accuracy, we want to see how close the measurement comes to the actual value. Well, the actual value is 2.71. So none of these really come super close to 2.71. So you would not say that they are accurate, or you would say they are not accurate. Okay. Now, what about precision? It's a measure of how close a series of measurements are to one another. And a series just means multiple measurements. And so is 4 and 2 and 1 close to one another? And the answer there is a resounding no, so they are not precise. So it's not accurate and it's not precise. And that's how you tell those type of questions. All right, let's look at another example. Let's say that I did another trial, I did another experiment, and this time I got 2.70 grams per milliliter, 2.71 grams per milliliter, and 2.71 grams per milliliter. And if I were to ask you about the accuracy or how close a measurement comes to the actual value, well, I have to compare my experimental values to my actual value to know this. So if my actual value is 2.71 and I look at my experimental values or an average of them, and we would get something really close to 2.71 because we have 2.70, 2.71, and 2.71. So we would definitely say these are accurate. These are accurate. All right. But are they precise? Well, let's see. Are the series of measurements close to one another? Is 2.70 a close value to 2.71? And is 2.71 a close value to 2.71? And we would have to say, yes, all these values, all 3 of these values are really close to one another. So they are precise. So in this case, they are accurate and precise. All right, let's look at one more scenario. All right, let's look at one more scenario. All right, so in this case, we have, let's say we have something like, there's something like 8 grams per milliliter, 3.8 grams per milliliter, and 3.8 grams per milliliter. And we want to know whether these are accurate or precise. If we look at the results and we compare them for accuracy to the reliable source or the actual value, we see that 2.71 and 3.8 are quite different. And so we would definitely say they are not accurate. All right, but we would say that 3.8 and 3.8 and 3.8 are really close to one another. As a matter of fact, they're all 3 the same. They don't have to be the same to be precise, but they're definitely, if they are the same, they are definitely precise, but they would have to be close to one another. And so this is precise. All right, and so that's what that is about there. Okay, so just 1 second. Okay, so now we have determined that this is not accurate, but it is precise. So now we might want to ask another question like, well, what is the error? Well, error is equal to the experimental value minus the accepted value. Okay, so what is my experimental value? Where did you get the experimental value from? And earlier we said we get our experimental values from our table. So our experimental value, let's write this, error is equal to our experimental value, which is 3.8 grams per milliliter, minus 2.71 grams per milliliter. And so our error, 1.09 grams per milliliter. All right, so there's our error. All right, now what about our percent error? A percent error is equal to the absolute value of our error. That just means we don't have to consider the sign. So we have 1.09 grams per milliliter. And then our accepted value is 2.71. This AV stands for accepted value. It is 2.71 grams per milliliter. And then you simply take that value and you multiply it by 100. So what do we get? We should get 1.09 divided by 2.71. All right. And that gives you 0.4022 times 100. And if we multiply that out, we should get 40.22%. All right. So one thing I want to point out is that these units right here cancel. Grams per milliliter divided by grams per milliliter, they cancel. That's why you're only left with percentage as your answer. And so that should help you out quite a bit. All right, now let's go over here, and we have a couple scenarios that we had in the lab. And let's say that we come up with some values here. Let's say we have a mass of an empty graduated cylinder, and that it is, let's say, 20 grams. And the mass of the graduated cylinder with liquid, let's say that it is 40 grams. We're just making up some values. And let's say the volume of this liquid is 20 cubic centimeters. All right, so what we have to do is then figure out what is the mass of the liquid and then what is the density. So these values that I just wrote in, I just made them up. They will be given to you in a data table. They weren't given to you in the lab. You actually had to weigh the mass. You had to mass the graduated cylinder. You mass the graduated cylinder with liquid, but then you had to find this mass of the liquid, knowing those two things. So those values will be given to you, even though you would in the lab you would figure those out yourself. And then the volume, you would know the volume that you placed in the graduated cylinder. Okay, so how do we get the mass of the liquid? All right, the mass of the liquid is equal to the graduated cylinder. I'm going to put graduated cylinder with a liquid, all right, minus the graduated cylinder without, all right, or empty, all right. And so what is the mass of the graduated cylinder? It is 40 grams. What is the mass of the graduated cylinder without the liquid or empty? It is 20 grams. And so the mass of the liquid then is 40 minus 20, which is 20 grams. And so you know that the mass of the liquid is 20 grams. All right, and I just fill that in. All right, so there's our answer right there. All right, for the mass of the liquid. Now, what if I ask you, what is the density? And I'm putting a question mark there. What is the density? Well, how do you get the density? Well, that's easy. Density is equal to mass over volume. Whoa. All right, density is equal to mass over volume. And the mass, you already determined it. It's 20 grams. And the volume was given to us. It is 20 cubic centimeters. And so 20 grams divided by 20 cubic centimeters. What's 20 divided by 20? Yeah, that's right. It is 1 gram per cubic centimeter. And so that is all you have to do. The answer to this is 1 gram per cubic centimeter. All right. And that's it. And if we wanted to, we could put the units here, even though it is stated right there. Okay. So there comes one more type of question. That type of question is, what is the mass, or excuse me, what is the volume of a solid? What is the density of a solid? All right, and so you have to be given some of these things. And just to keep this fluid, I just decided to make up some values on the fly. So we're going to use our mass. Let's go with 40 grams. And let's say our initial volume is, let's say our initial volume is 20 milliliters. And let's say our final volume is 60 milliliters. All right, so we need to know what the volume of the solid is. All right, so the volume of the solid, and this is some type of irregular shape in the lab, it was the piece of metal. Volume of the solid is going to be equal to VF, or the final volume, minus VI, the initial volume. All right, and so initial meaning the beginning. So the final volume is 60 milliliters. The initial volume is 20 milliliters. And so that gives you an answer of 40 milliliters. So what is the volume of the solid? It is 40 milliliters. So what is the density? Well, this is easy. Density is equal to mass over volume. The mass, according to our data table, is 40 grams. And the volume is 40 milliliters. And 40 divided by 40 is 1 gram per milliliter. And so there's our answer. All right. And then we have one more type of problem. And it says to express 259,987 seconds in weeks. All right. So your question becomes, I have 259,987 seconds is equal to blank number of weeks. All right, and so we start a bracket with 259,987 seconds. We know seconds, look at the unit here at the top, is going to be the same at the unit at the bottom. And what are we going to go to? Are we going to go to a smaller unit or a larger unit? You know, we're going to go to a larger unit because we're going from smaller unit seconds to larger unit weeks. So we know from seconds to minutes. All right, and once again, minutes is going to go to the bottom because minutes is at the top. These are going to cancel. It's going to go to hours. Hours is going to go to days. And then day to week. And we know we're done because we're at week and week. All right, so we know there are 60 seconds in 1 minute, 60 minutes in 1 hour, 24 hours in 1 day, and 7 days in 1 week. So I'm going to put this in your calculator. And you should get, for your denominator, let's put this down here for your denominator. You should get 604,800 divided by, or divided into 259,987. All right. And so what is our only unit that we have left? We should see that we have seconds cancel, minutes cancel, hours cancel, days cancel. So we're left with one unit, and that is week. And so we have, I'm sorry about my handwriting, it's not very good. We have 259,987 divided by 604,800, and that will equal 0.4298726 weeks. So how many sig figs can I have? Well, in my original problem, I had 6, so I can have 6 here. 1, 2, 3, 4, 5, 6. I look to my 7th. It is greater than 5, so I am going to round that 2 to a 3. And it would be 0.429873 weeks. All right. Or you can say 4.29873 times 10 to the negative 1 weeks. You could say that either way. Okay, so that is your conversion problems and everything there. So we just now have a simple Edpuzzle question for you. Okay, so look at the data table that I have here, and you're going to use this to answer a question in Edpuzzle. So take a look at this, and then a question will arise in Edpuzzle shortly. Okay, for our next question, I have table A and table B. You're going to use those to answer a couple of questions. Puzzle, a chance to look at those. Of course, you can always go back and look at the data tables to help you if you need to reference them. And then lastly, I have one simple question for you. How many seconds are in 4.187 hours? And so you're going to answer that in Edpuzzle as well. Okay, I wish you the best of luck in answering all your questions and preparing for your next attempt on the exam. Thank you for watching, and tell your friends. All right.